Okay, hello fourth graders. Welcome to another science video test review lesson. Today we're going to be talking about static electricity. I guess the first thing that we need to remember is that matter is made up of atoms. Here's a picture of an atom here. I should almost make this red just for it's a little bit clearer for you to understand, because that's how I have it in my notes. So let me make this change real quick. Okay, here is a picture of an atom. Now, remember, the protons that are in the nucleus are positively charged. Inside the nucleus, next to the protons, you have neutrons. Neutrons are neutral. They don't have any charge. So, protons are positive, and neutrons are neutral. Protons, positively charged. Neutrons, which are in the nucleus, they're blue and the brown, are neutrons, neutral. Okay, so those are the charges, now that I've completely embarrassed myself. The electrons, the things that fly around the nucleus, are negatively charged. Okay, so matter is made up of these atoms. Okay. Now, it's also important to keep in mind. Well, let me continue. You also need to understand this here, that protons, or things that have the exact same charge, will repel one another. So if you have two positively charged things, they are going to repel. If you have two negatively charged things, they are going to repel. So if they have the exact same charge, positive and positive, they're going to repel. If they are negative and negative, they're going to repel. They're going to want to go away from one another. If they have a different charge, if one is negative and one is positive, they will be attracted to one another. Okay? So they only are attracted together if they have different charges. So keep that in mind and this in mind. Okay? Now, because matter, anything that has mass and takes up space, is made up of atoms, and atoms are made up of positive and negative particles, matter is going to have an electrical charge to it. Electrical charge is a property of matter that tells you whether something is positive or negative. So, an electrical charge is something that everything has that's made up of matter. Okay, because matter is made up of atoms. Atoms have positive and negative charges. That means anything that is made up of matter has an electrical charge, whether it be positive or negative. Now, it's just the case that most things in nature are balanced. They have the same amount of positive charge and the same amount of negative charge. Okay? So, just keep that in mind. Most things in nature have the exact same amount of positive charge and negative charge inside them. Once again, most things in nature have the same amount of positive charge and negative charge inside them. They have the exact same amount of both. Same amount of positive charge, same amount of negative charge inside of them. Most things in nature. Okay? How static electricity happens is when you rub things or touch things up against one another. The reason static electricity happens when you do that to things that are made up of atoms, which is matter, is here. It's called buildup. Okay? Now you can see here in picture number 1, this is a neutral balloon, which is like most things in nature. It has the same amount of positive and the same amount of negatively charged particles inside of it. So you can see there's 3 positives and 3 negatives. It's balanced. Okay, it has the same amount of both. Now, if I were to rub this neutral balloon up against this neutral piece of wool cloth. This is a piece of wool. You can see the wool cloth is also neutral. It has 2 positive and 2 negatives. But if you rub those together, an interesting thing happens. Negatively charged particles can go from one thing to another easier than positively charged things. So when I rub these together, negatively charged atoms jump over to the piece of wool. So you can see here the balloon in step number 2, an electrical charge, an electron, has come over to the balloon. So the wool cloth has lost 1 electrical charge. That electrical charge has now gone to the balloon. This happened because of the rubbing together. Negatively charged particles tend to jump from one thing to another easier than positively charged things. So you can see here the negative charge jumped to the balloon because of the rubbing together. If you want to think about it, the balloon kind of grabbed the electron off of the wool cloth. It grabbed it. When it was rubbing, the balloon went grab, and it grabbed that negative charge. Okay? Now that that balloon has 1 more negative charge, it's no longer balanced. It has 4 negative charges and only 3 positive charges. Whatever has the most charge to it, that's what its overall charge is going to be. So if you look at here, if it has the same, it's neutral. If it has more positive than negatives, it has an overall charge of positive. These are balloons, by the way. So that balloon's overall charge is positive. This balloon's overall charge is negative. Okay? The reason this one is positive is because it has more positive charges than negative. The reason this one is negative is that it has more negative charges than positives. If it has the same, it's neutral. So going back to our example here, when you rub those together, you have 2 neutral things that you rub together, but the balloon grabbed a negative charge off of the wool cloth. Now the balloon is negatively charged because it has an overall charge of reds, negative charge, because it has 1 more negative charge than blue. The piece of wool cloth now is positively charged because it has 1 more positive charge in it. It's 2 to 1. Okay, so it's going to be positively charged. Like we talked about over here, positive and negative things are going to be attracted to one another. So at first, the piece of wool and the balloon, they weren't attracted to one another. You had to grab them and force them together and rub them. But now that you have rubbed them together, you have created an unequal balance between the 2 of them. Now this one has more negative, this one has more positive now. It's unequal. Because it's unequal, they are now going to be attracted to one another because there is a difference. This one has an overall charge of negative, this one has an overall charge of positive, so they are going to be attracted to one another now. All right? So we talked about overall charge, we talked about buildup. You can see that this balloon has a buildup of negative ones now. This piece of wool cloth has a buildup of positively charged ones now. Move over here. So static electricity, thinking about all that we've talked about, is a buildup of electrical charges in an object. Okay? So this balloon has static electricity. This balloon has static electricity because it has a buildup of negative charges. The piece of wool cloth has static electricity because it has a buildup of positive charges. All right? So anything, as long as it has a buildup of negative or a buildup of positive, is going to have static electricity. If it has buildup, it has static electricity. All right? Now, what happens is if I walk up to a door handle that has a buildup of either negative or positive charges, it's going to have some static electricity to it. Okay, so if I walk up to it, and let's say I'm positively charged. Okay, I have a few more positive charges than negative charges in me because I rubbed the ground. So I lost a few negative charges to the carpet as I'm walking. The carpet grabbed a couple negative charges off of me. Okay, so now I'm positively charged because I lost a couple negative ones. I walk up to a door handle that is negatively charged. When I go and touch it, because they're attracted to one another, electricity is going to flow between them. All right? So, and that is the discharge, a release of electricity through one object to another. The door handle is negatively charged. I am positively charged because I lost a couple negative charges on the carpet. When I go and touch the door, the negative and the positive is going to attract one another, and there's going to be an exchange of negative or positive electrons between us. Okay, I'm going to give up some, they're going to give me some. Because we're imbalanced, I need something and the door handle needs something. I need some more negative charges because I lost some on the carpet. The door handle needs some positive ones, or it needs some negative ones, however you want to look at it, because somebody maybe scraped them off the door handle, whatever the case may be. So when we touch, static electricity or a discharge is going to happen. This is also how lightning works, okay? If you have a buildup of negative charges in the clouds, and you have a buildup of positive charges on the ground, you have static electricity here and static electricity here now because you have a buildup. When there is a difference, when they are different, right? Negative is different than positive. They are going to now be attracted to one another. That attraction is going to cause the electricity, and that's how lightning happens. The negatively charged clouds and the positively charged ground, the electrons are going to shoot down into the positively charged ground. All right? Keeping in mind here, now, there are things that stop electricity from happening. Like, if you notice, your computer cords have rubber around the wires. Rubber is an insulator. Rubber stops electrical charges from happening. Rubber is an insulator which stops electrical charges from happening. Okay, so anything that stops electrical charges from happening are called insulators. Rubber is a good example of an insulator. That's why we put those around our wires. Now, wires is a good conductor of electricity. That's why we use them, for our computer cables. Okay. Conductors are materials that let electricity flow easily. So wires are conductors because they let electricity flow easily. Rubber is an insulator because it does not allow electricity to flow easily. That's why we put them around wires, so that when we go and grab our computer cable, we don't get electrocuted. But we do want wire inside of the rubber because that is what's carrying our electrical message when we're typing on our computers. Okay? I believe we've covered up everything. It was definitely a lot. Static electricity is kind of a tough thing to understand, but we've talked about it in class. We've done all of the vocabulary pages. You should be ready to go for the test. And if you have any questions, I'll be on Edmodo, Facebook. Feel free to talk to me in class, and watch this video a couple times. Feel free to pause it, study your vocabulary notes, and you should be ready for the test. I'll see you guys tomorrow in science class.